Today we will be seeing how to build a deep learning model for classification of images. First, we will be requiring some libraries like NumPy, sklearn, TensorFlow, etc. First step is to import all the libraries, and then in this cell, if you have GPU, then you can run this model on the GPU. You can check by this code if you have GPU or not, and then I will run this model on the GPU. For running this model on the GPU, write this line of code. And as we can see, we have our images for training the neural network here. You can see this is an apple. So now we'll walk through this directory fruit images. We will set this part for the training data and testing data. Now we will do pre-processing on this data. We will normalize this data for working of the better efficiently for the model. Here. Now we will load this data into here training set and test set. We can load the data train by direct this function, which is available in the TensorFlow library. As you can see here, we have loaded the data which was in the training path, and we have set the image size of 100 by 100 pixels. As you can see, there are 67,692 images belonging to 131 classes. Now we will see the labels. We can see here all the 131 labels, starting from the apple to watermelon. Now we will build our deep learning model, which we will be using for the image classification. We will be using the sequential series for adding all the layers. We will be using three convolutional neural layer in each this layer. In each convolutional neural layer, there are three parts. First is the convolution, then there is a batch normalization, then we are max pooling, then dropout. Here we are repeating it three times. And here we are using the activation function ReLU, which is also known as rectified linear unit. As you can see, our input image is coming in 100 by 100 pixels. And then after the max pooling, we are reducing the image size to 50 by 50. As you can see here, reducing size by 2 by 2. And in the last layer, since we all know that image is an n-dimensional array of pixels, so we are converting this n-dimensional array to the one vector, which we will give it to the dense layer, and this will give us different class. So we are running this cell, and our model has been created. Now we'll see the summary of the model. We can see our model is sequential model, and we have used convolutional layer, then batch normalization layer, max pooling layer, then dropout, again convolutional, batch normalization, max pooling, dropout, again convolutional, and at the last we have used dense layer. Here we can see there are 131 neurons because our labels are 131, and we can see we have given the first image 100 by 100 pixels, and then in the max pooling it is reduced by 50 by 50. We can see here because we have written 2 by 2. So the we have reduced by 2 by 2, 100 by 2. And now here uh, again in the 50 by 50 image size is coming, and we have reduced again 2 by 2, so the image size becomes 25 by 25. Then again convolutional layer we have given 20 by 25 pixel image, and then again it is reduced by 12 by 12, and this at the end we got 118,432 uh, values, which is in the one vector, and then we have given it to the dense layer. Now we will be compiling this model. For compiling, we will be using loss function. The loss function we are using is categorical cross entropy function, because we are classifying. And for optimizing, we will be using RMS prop function. Now we will just train our data. So we can see we can train our data by using fit method, which is available for the model. We are using the training set for the training, and we will be training 30 times, and in each training time we'll be using 50 steps, and we will be also using the validation data for testing the model. So it will take time here. I'll just pause for some time. So as we can see, our model has been trained. There are We have trained it 30 times, and in each time there are 50 steps. We can see here the loss function is decreasing as we go, as we train the model, and the accuracy increases as we train the model. So we'll be checking this increasing, or so we can see here the first loss function is decreasing with the iteration, every iteration, and the accuracy is increasing with every iteration. We have also plotted the validation loss and validation accuracy. Now we will test our model on the test image. So I have taken the next test set, and we'll see. As we can see, the true label was avocado, and the machine has predicted avocado. And uh, we'll again test the model. So we can see here the machine has predicted wrong, and now the machine has predicted right. It is cucumber ripe too, cherry wax yellow, and it's wrong. Now we will be saving the model here. I'm saving this model as final2.h5. H5 is in serialization format, so I'm saving this model, and we can see here final2.h5 has been created file. So our model has been created and saved.